Okay, we're going to talk briefly about vectors here. I've drawn two vectors, and a vector just simply has direction and size, or something we call magnitude. When you look at this one here, here's a vector starts at 0, 0. Okay, so it starts at 0, 0, and it goes all the way up to 3, 5. So it goes up to 3, 5. This vector right here, okay, is pointing kind of upwards into the somewhere in the first quadrant here. Just a reminder here, that's number 1, 2, 3, and 4. Okay, so you go into the first quadrant. If I look at this vector here, I could figure out the size of this vector. Again, the size, or the fancy word is the, I'll just write it out here, is the magnitude. Okay, in order to figure out the magnitude, I basically have to figure out the distance of this. Okay, in order to figure out the distance of this, what I could use is the distance formula. Instead, I'm going to use, of course, another I guess variation of the distance formula, which simply is using Pythagoras. And so what I do is I figure out, well, how far am I moving to the right, or in the x direction? So in other words, I'm just looking here, I'm going to draw another triangle here just right beside this. I'm moving 3 units to the right, and I move 5 units up. How do I know that? Well, I started at 0 and ended at 3, and I went from 0 to 5. So in other words, this has a length of 3, this has a length of 5. Okay, and so what I'm going to do is to figure out this, I'm going to say, well, if I call this h for the hypotenuse, let's say, well, h would equal, okay, 3 squared plus 5 squared, and then I'm going to square root that. So it's really the square root of 9 plus 25, which is the root of 34. So this has a length of the root of 34. It's some number. We could do that in our calculator, but that's what it ends up being. That's what h ends up being. There's something called vector component form, and vector component form is actually quite simple. It just simply says, rather than knowing this, okay, rather than knowing the magnitude or the size of the vector, I want to know its components. In other words, what is it made up of in terms of x and y? And so what I do is I say, well, I know it went plus 3 over, and it went plus 5 up. And so I write that this vector right here, okay, this one, could be written as 3, 5. And notice I put these kind of brackets around there. I'm not putting parentheses because then it is a point. Okay, so here's a point, and this is 3, 5. And this is how to do vector notation. Again, once you know this, it's easy to find the magnitude, because I can simply say, well, it went over by 3, so I can go 3 squared and up 5, 5 squared. I could get the magnitude very quickly from here. The difficult part is how to draw this, though. Okay, it's impossible to draw this drawing on a graph, because I can only get the shape of it. In other words, I know it went over by 3 and up by 5. Okay, it looks something like this. There's my vector. I just don't know where to put this, because I don't know the starting and the end point. So I don't know where to put this on the graph. I need to be given more like, oh, it starts at 0, 0. Then I know where to put this, okay, this vector. But I need to give more. But I can get the size of it and the general shape of it from the vector component form. If I look at one like this, I drew this one here, and it's hard to see the numbers here, but this is -1, -5. Okay, right there is -1, -5. And this is -4, -2. So just take a moment and see if you can write the vector component form of this. Okay, well, it's going to look like this. It basically went this far that way and this far up. Well, let's figure out what that is. It went from -1 to -4. So in other words, this moved a distance again of 3. This went from -5 to -2, and it went again 3. Now, it is moving to the left or to the negative direction. Okay, so if I'm writing this in vector component form, I'm going to say it went -3 because it's going to the left or to the negative. We lost 3 going this way, but we gained 3 going up. So it's +3. So this would be the vector component form of this vector right here in black. Okay, this is the component form. To get the magnitude of this, I'm going to say, well, that's going to be 3 squared plus 3 squared, and then square root it. So I basically get the root of 18. Okay, so I can get the root of 18. So I get 3 squared plus 3 squared, I can get the root of 18. And that's how to get these vectors in component form. One last thing I'm going to show you here is, beyond that, if we're just going to add and subtract basic vectors, if you look at this one here, it says 1, 3, and 2, negative 4. Here are two vectors. Of course, I could draw these and I say, well, that one went over by 1, up by 3. So there's the vector for that first one. This one went over by 2 and down by 4. And so there's the vector. So these are the two vectors. If I'm going to add these, it's really quite simple. I simply add only the x's and only the y's. And so this would look like 1 plus 2. I'm going to get 3. That's 1 plus 2. And then 3 plus negative 4 will give me negative 1. That is how to do arithmetic there. It's going to be 3 comma negative 1. Same thing if I had subtraction. Let's say the exact same thing. Same vectors. 1 comma 3 minus 2 comma negative 4. This one's going to be 1 minus 2, which gives me negative 1. And then 3 minus minus 4 will give me 7. So it'll be 1, 7. So just in terms of adding and subtracting, that's probably a really, really simple thing to do.